Here's a video about the center radius form of a circle. We have two pictures. I took the liberty of drawing the pictures before I started the video of circles, and we'd like to come up with an equation for those circles that makes use of the obvious facts, the center and the radius. So here you can see, since I'm going through this point, which happens to be 0, 1, and this point, which happens to be 2, 1, the radius is pretty clearly 2, and the center is at 2, 1. Well, is there a way to exploit that to make an equation that describes every point on that circle? Well, there is, and it has to do with the distance formula. You remember that the distance formula says that the distance between two things is the square of their difference in x values. So let's imagine I had a point xy here. Their x values, so x minus 2 squared plus y minus 1 squared, the square root of that would be the distance between the two. So if I'm looking at the distance of that red line, that would be how I'd calculate it. And so that's supposed to be equal to the distance, or on a circle, of course, we call that the radius. So if that's what you have, then the equation for that black circle might be simpler if you just squared both sides. So we would get x minus 2 squared plus y minus 1 squared. Well, what's the radius of this circle supposed to be? It's supposed to be 2. So we have 2 now squared. This is called the center radius form of a circle, okay? And the reason that it's called that is pretty clear, hopefully. You can read off where the center is. The center is at the point 2, 1, and the radius is 2. So center, 2, 1, radius 2. See that? And so there's actually a general form for that. So that form can be written x minus h squared plus y minus k squared equals r squared, with center hk and radius r. But I have a couple other examples here just so we can practice. Okay, so notice we've got the center here, and also we should be able to count up. Given any 2 points, by the way, you can find the radius by using the distance formula. I just picked one where the distance would be easy. Okay, so the distance between these 2 points, because they're directly above each other, you could use the distance formula, but it's simpler somehow in this case to say, hey, the radius is 4. Using this general form, we have x minus 2 squared plus y minus, notice that the center, the y value for the center is -3. So that's minus -3 becomes y plus 3 equals 4 squared. And you could actually check, you could check that every point here goes, actually satisfies that equation. So for instance, if the radius is really 4, you ought to go left 4. You've got a point here that is -2, -3. That's a really ugly 3. But the point is, if you plugged in that point in here, if you plugged in -2 for x, you would get out -4. -4 squared is 16. If you plugged in -3 for y, you get 0 squared. So 16 plus 0 squared is equal to 16, right? Every point on that black line satisfies this equation. Every point that's not on the black line doesn't satisfy the equation. That's why it's the equation for a circle. You can go backwards too. So over here I made 2 graphs. Let's try and come up with 2 equations in this form, and then we'll go ahead and plot them. So let's see, let's do x plus 2 plus y minus 1 equals 3 squared. Okay, so let's say you had this equation in center radius form. I'd first off take that center. I'd say, the center is at -2, 1. The radius is equal to 3. So count over to the center point, then count in every direction 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And then we'd make our best shot at connecting the dots, and we would kind of be generous and pretend like I drew a circle. If everything was to scale, it would be perfectly a circle. And we could do the same thing down here. X plus 1 squared plus y plus 1 squared equals 2 squared. Okay, now here the center is at -1, -1. I'm reading that off, minus -1 minus -1. And the radius is 2. So I come to the point -1, -1. Then I go 2 in every direction, 2 to the right, 2 up, 2 to the left, 2 down. Include 2 in that direction, 2 in that direction, and there is my circle from the center radius form.